Hello and welcome to Algebra II Lesson 7. In this video, we're going to have an introduction to applications of linear equations. So one of the most difficult things you're going to do in an Algebra 1, an Algebra 2, or even a college algebra course is learn how to set up and solve word problems. I know if you've done them in Algebra 1, it's something where a lot of students just struggle because you have to generate your own equation before you even struggle to solve it. But one of the things that can help us, if we just start out with some very, very easy problems, and we learn how to correctly interpret some of the language that we're going to encounter with a word problem, I think it's going to put us a step ahead when we start seeing stuff that's very challenging. So let's begin by looking at common addition phrases, and then we'll move into subtraction and multiplication and division. So the first one I have here is the sum of. So it's obviously telling us to add. We know the sum is a result of adding. So if I see something like the sum of, let's say, a number and 5, how could I represent that? Well, a number is just some unknown number. We can use a variable like x or y or whatever you want to use to represent that. So if I reread this as the sum of x and 5, that would be x plus 5. Then you have something like more than. If I saw a phrase that said 3 more than a number. So let's say I saw 3 more than a number. And again, when we see a number, we can use a variable. Let's use y this time to represent that. So if I saw 3 more than y, that's just y plus 3 or 3 plus y. Remember, addition is commutative. So when you translate stuff with addition, the order is not important. So I could put 3 plus y or y plus 3, and it's completely irrelevant because I would have the same answer either way. What about just plus, right? The plus that we often hear with addition. Well, I could say something like -7 plus a number. So I could say -7 plus a number. And let's use z to represent a number. So I would have -7 plus z. Then we also see something like added to. So if I said a number added to -2. So let's do a number added to -2. What would that be? Well, I can use, again, a variable to represent a number. Let's use, I don't know, q, for example. So if I said q added to -2, then I would have q plus -2. Or again, I could put -2 plus q. Again, addition is commutative, so the order is not important. What about something like increased by? If I saw a number increased by 17. So a number increased by, let's say 17. Well, again, a number, let's use r in this example. So let's say r increased by 17. So we just have r, and then if I'm increasing it, I'm adding. So I'm just adding what it's increased by, which is 17. So this is r plus 17. So you can see with addition, it's very, very easy. The translation is straightforward. And remember, when you're adding things, the order is not important. So let's talk a little bit about some phrases for subtraction. So we have less than. So let me scroll down a little bit. For less than, let's use the example of 6 less than a number. So let's put 6 less than a number. And I want you to pause the video for a second. Let's just use x to represent a number. And when you pause the video, I want you to try to write this phrase. Now, hopefully you tried this, and I want to walk you through this real fast. 6 less than a number. So that means I have some number, and I represented that with x, and I want 6 less than that. So I start out with this, and I subtract away 6. Okay? If I put 6 minus x, that would be wrong. This is wrong. This would be 6 less a number, okay? With subtraction, the wording is important, okay? Because subtraction is not commutative. If I have 1 minus 2, that's not equal to 2 minus 1, right? I can't just flip the order there. It's not like addition, whereas if I have 1 plus 2, that's the same as 2 plus 1. Okay, again, subtraction is not commutative. Now, on this one where we have less, I can show you. Let's say I had 6 less a number. Well, in this case, this translates to literally 6 minus, and then whatever we use for our variable, in this case, let's use x again. So this is 6 minus x. So again, notice the difference between the two. In this example, we have 6 less than a number, implying that we start out with the number, which is x, and then we're 6 less than that, so we just subtract away 6. In this example, it's 6 less, just less, a number. So 6 less a number, which we represented with x. So again, very important that you understand what you're being asked. Take your time when you're reading these things, especially at first, and ensure that you are translating them correctly, because if you don't, most of the time you will get the wrong answer. All right, so next we see decreased by. So as an example, let's say I have a number. So a number, and it's decreased by, let's say 8. So let's say the number here, we represent that with y. So y decreased by 8 would simply be y, and then it's decreased, or we're subtracting away 8. So very, very simple. Then as another one, let's say we see minus. We know minus means subtract. So let's say I saw 4 minus a number. Very straightforward. If I use, let's say, z to represent a number, then that's just 4 minus, okay, minus z. All right, for the last one for subtraction, let's look at subtracted from. So let's say as an example, I say a number. So a number subtracted from, I don't know, let's say 11. So a number, let's represent that with, I don't know, let's go with q again. So let's say q subtracted from 11. So if it's subtracted from 11, that means I'm starting out with 11, and from that, I'm subtracting this number q. So that's 11 minus q. And again, this is one of those ones where it's very easy to make a mistake. If you put q minus 11, again, that's not going to be right. You need to make sure that you translate this as q subtracted from, this is the key thing here. It's subtracted from 11. So that means I have 11, and then I'm subtracting away q. All right, so now let's look at multiplication. And with the phrases for multiplication, again, multiplication and addition are commutative, so we're not going to have the same issue with subtraction. If I have 6 times 3, that's the same as 3 times 6. So the order with multiplication is not important. So we start out with something very simple like times. So if I have, let's say, 9 times a number. And with a number, I can just represent that with, let's say, x again. So 9 times x would just be 9x. The next one is also obvious. You have multiplied by. So if you saw something like a number multiplied by, let's say, -7. With a number, I could represent that with anything. Let's say r. So let's say r multiplied by -7. That's -7 times r, which we write -7r. Next, we see of. And we generally see of when we're talking about fractions, right? You might see something that says 1/3 of a number. So of, let's put 1/3 of a number. And let's represent a number with, let's go with x again. So 1/3 of x just means 1/3 x. It'd be like if your paycheck was $3 and I said, give me 1/3 of your $3, I would get $1. All right, the last one we're going to look at with multiplication is product of. And for this one, we could just say the product of a number and let's say negative 15. So the product of a number, which I'll represent with, let's say, y, and negative 15, it would be negative 15 times y, or just negative 15y. All right, lastly, let's look at some phrases for division. Again, remember, division is also not commutative. If I have, 10 over 2, that's not the same as 2 over 10. Right? These are not equal to each other. So when we look at phrases for division, we start out with the quotient of. So let's say I had the quotient of 7 and a number. So this would tell me that I have the quotient of 7. 7 is going to be the numerator. And a number is going to be in the denominator. And I'll represent a number with just x. So this would translate into 7 over x. The other one we really see with division a lot is divided by, which obviously makes sense. And you see something like a number divided by, let's say, negative 2. Now, a number, let's represent this with z. So a number, so z, divided by negative 2 would just be z over negative 2. And again, when you encounter phrases with subtraction and division, you have to be extra careful to read your wording and interpret it correctly. All right, so the last thing we want to know before we start looking at some problems is means equals. So that's the translation when we're looking at a word problem. All right, so let's look at some sample problems. So here's the first one. We have 5 times a number plus 7 times the number is 24. Find the number. So the first thing I like to do when I encounter these is I represent a number or the number or whatever it is that's unknown with a variable. So let's line this out and just put x there. Let's line this out and just put x there. So 5 times x is 5x. Plus means to add. 7 times x means equals, and then 24. Very, very simple once you do that. So I've just translated this to this. And now that I have an equation, it's very, very easy to solve and find the number, okay? So 5x plus 7x, we combine like terms there, we get 12x. And this equals 24. We divide both sides of the equation by 12. And we get that x is equal to 2. Or again, using solution set notation, we say that this set contains the element 2. Now, when you solve a word problem, you generally want to answer with a nice little neat sentence. So we can just make something really simple and say the number is 2. Or we can just put the number is 2 like this. Either way. All right, let's take a look at another one. So we have a number less twice the number is negative 5. Find the number. So again, everywhere I see something like that, I'm going to replace it. So let's just line this out and put x or y or z or whatever you want to use. So x less twice the number, so let's line this out and put x, is negative 5. So let's put equals here. Okay, so now I have x less. So I know that that means I have x, and then I'm subtracting away because I see less, twice x, so that's 2 times x, and then equals for is negative 5. Again, once you kind of label things like this, it's very easy to go from this to this, okay? So now I have x minus 2x, that's negative x, and this equals negative 5. If I multiply both sides of the equation by negative 1, or divide by negative 1, whatever you want to do there, this cancels with this, and I have x is equal to negative 5 times negative 1 is 5. So find the number is 5. Okay, let's look at one that's a little bit more complicated now. So when 8 is multiplied by the sum of, and then we have a number times 7 and negative 8, the result is we have 6 times the number plus 36. And then we just want to find the number. There's a few things in here that can really trip you up if you've never done any of these problems. So the first thing is that we're going to be using our distributive property here. I want you to recall if I have something like 5 times, let's say I just write 2 plus 3 like this. I would do 5 times 2 plus 5 times 3. And that gives me 10 plus 15, which equals 25. I know that if I combine 2 and 3 through addition, I'd have 5. 5 times 5 is 25. In the case where we have a variable involved, we know that we could say we had the sum of, let's say, 2x plus 3. Now I can't combine these because they're not like terms. So in this case, I do 5 times 2x and I get 10x plus 5 times 3, which is 15. So if I had told you I have 5 times the sum of 2x plus 3, you would have to write it this way because 5 has to be multiplied by the 2x and the 3. I can't just write it like this, which is a common mistake. Right? Now I'm just multiplying 5 times 2x. I'm forgetting about the 3. So it's important you understand that before we start trying to attack this problem. So again, when 8 is multiplied by the sum of a number, and I'll replace this with x, and it's being multiplied times 7, so this would really be what? Let's just write this whole thing as 7x. Makes it nice and simple. So let me reread. When 8 is multiplied by the sum of 7x and negative 8. So 8 is multiplied by the sum of 7x and negative 8. 7x plus negative 8 or 7x minus 8. But it's important that 8 be multiplied by 7x and also negative 8, which is why I used parentheses here. Okay? Very important, just like what I just did over there. All right, so once we get past that, we say the result is, so that means equals. And then we have 6 times the number. We represented the number or a number with x. So we have 6 times x, which is 6x, then plus 36. So again, once you start doing this enough, you'll recognize what's going on, and you'll be able to translate these very quickly. The key trap here would not be putting parentheses around the sum of 7x and negative 8, right? So 7x minus 8. So 8 times 7x is 56x, and then 8 times negative 8 is minus 64. We have this equals 6x plus 36. So now I want all my variable terms on one side, all my numbers on the other. So minus 6x, plus 64, plus 64. So this will cancel, and this will cancel. So we'll have 50x is equal to 36 plus 64 is going to give us 100. We divide both sides of the equation by 50, and we get x is equal to 2. So when we answer this, find the number. Again, we could just say the number is 2. All right, let's take a look at one more problem. So the quotient of negative 11 and 3 is added to 3 times a quantity. The result is the number less the quotient of 8 and 3. Find the number. Again, these seem kind of difficult. They seem kind of really wordy, but if you go step by step, it's not that bad. So the quotient of negative 11 and 3, that's negative 11 divided by 3. Very simple. So is added to, just means plus 3 times a quantity. So what can we say? We can say a quantity is just x. So 3 times x is just 3x. The result is means equals the number, which we said was x. Then we have less, which means to subtract. So we're subtracting away. Then we have the quotient of 8 and 3. So that's 8 over 3. So again, it looks complicated, but once you go step by step, it's really not. So again, we just want to find the number. So let's scroll down a little bit. And I'm going to multiply both sides of the equation by 3. Just so that I don't have a denominator involved. 3 times negative 11 thirds is negative 11, plus 3 times 3x is 9x. This equals 3 times x, that's 3x, minus 3 times 8 thirds would be 8. Again, I want all my variable terms on one side, all my numbers on the other. So I'm going to add 11 to both sides of the equation. And I'm going to subtract 3x from both sides of the equation. And so this is going to cancel, and this is going to cancel. 9x minus 3x is 6x. Negative 8 plus 11 is 3. If we divide both sides of the equation by 6, we get that x is equal to 3 over 6 is basically 1/2, or you could say 0.5. So the number is 1/2.